Hello, this is a Room 35 production, and in this video, I plan to show you how to make a working electrical circuit which lights a light bulb using nothing but the materials you see on screen in front of you. Let's take a closer look at each material one by one. First, we have a cell holder. Now, I'm going to be using my pencil pointer to help you understand the cell holder. This part right here is called a Fosstock clip. It conducts electricity. It is in contact with this copper plate, which also conducts electricity, and you see that there is an identical arrangement on the left side. The blue part, this open space right here, is where the cell will sit, and the blue part itself is an insulator rather than a conductor. So we have the Fosstock clip, a copper plate right here, and a matching set on the other side. And that is the cell holder. Next, we have the cell itself, or the power source. This is a D cell, or a D battery. It operates on 1.5 volts. The part with the little knob here is the positive facing side of the battery, and if I turn the battery, you can see that the other side of the battery does not have a little knob, and that is the negative side of the battery. So essentially you can imagine electrons flying out this end through the wires and the light bulb and trying to get back into the positive end of the battery here, because negative is attracted to positive. Our next component of the circuit is a light bulb holder. Now we need to examine this quite carefully because a circuit only works in a circle. Here we have another Fosstock clip which is connected to this conducting plate. Notice there's space in between this conducting plate and the one below right here. There's air in between there. It is an open gap. When we install the light bulb into this holder, it closes the gap, therefore completing the electrical circuit. So the electricity will either flow through this Fosstock clip and plate, through the light bulb, and then out this plate and Fosstock clip, or the other way around. It will flow into this Fosstock clip and the lower plate, through the light bulb, and then back out the upper plate and through this Fosstock clip back to the cell. I kind of want to lift this up a little bit just so that you can see that there is indeed a gap between the upper clip and the upper plate and the lower plate. We're using two wires for this circuit. I just want to show you one because they're identical. The metallic part right here is made of copper. This is a conductor. This will allow electricity to travel through it. The red outer coating is an insulator. It will not allow electricity to travel through it. When attempting to construct your circuit, you're going to need to make sure that the conductor, or the copper part, is in contact with the conductor of your Fosstock clip on either your cell holder or your bulb holder. The final component of the circuit is the light bulb itself. The outer part of the light bulb is a conductor, and it screws into the bulb holder with these threads. I want you to pay special attention right now to this black piece of the light bulb. This black piece is an insulator. It does not allow electricity to travel through it, and its purpose is to separate the conductor at the bottom of the light bulb from the conductor on the side of the light bulb, so that a circle can be made through the light bulb and through the filament, which is the little metal part that ends up lighting up. Let me see if I can give you a closer look of the filament. It's going to be difficult to see because of the glare here. Maybe if I roll it around a little bit. The filament is a tiny piece of metal that goes from one of these copper prongs to the other copper prong, and it's made of a special metal which will glow when heated with 1.5 volts of electricity, which is exactly what comes out of our D cell. It will also be heated with other amounts of voltage, but it's intended for these purposes to be heated by 1.5 volts, 1.5 volts. For the first step of assembly, I have chosen to connect the wires to the cell holder. I want you to notice that the conductor of the wire is in contact with the Fosstock clip on both sides. The insulator is not interfering with or interrupting the flow of electricity through the Fosstock clip and the conductor of the wire. Now I have simply placed the cell into the cell holder, making sure that there's good contact between the copper plate in the negative side of the battery and the copper plate in the positive side of the battery. I'm nearly finished. I have now connected the conducting part of the wire with the conducting Fosstock clip and the lower plate, and the conducting part of this wire with the Fosstock clip connected and conducting through the upper plate. The final step is to install the light bulb. Now my light bulb has been installed, completing the circuit. I'm going to go ahead and turn the lights off to prove to you that I have a completed circuit with a working light bulb. And here we have the nice bright glowing bulb. The circuit is completed when the electrons from the negative side of the battery flow through this wire into the Fosstock clip, the lower plate. It goes from the lower plate through the bottom of the light bulb up through one of the prongs. When the electrons pass through the filament, it heats and glows. The electrons then flow through the other prong and out the upper plate into this Fosstock clip and back into the positive side of the battery, completing the circuit. This light bulb will glow until the filament burns through and no longer has a completes the bridge between the two prongs, or until this cell runs out of its energy. Thank you, and I hope you learned about simple circuits.